Good day everyone. So I will discuss the chapter 9 of Accounting Information System, 6th edition by James Hall, which is the data management system. So here are the objectives. First is problems inherent in the flat file approach to data management that gave rise to the database concept. Second is relationships among the defining elements of the database environment. Third is anomalies caused by unnormalized databases and the need for data normalization. Fourth is stages in database design, entity identification, data modeling, constructing the physical database, and preparing user views. And lastly is features of distributed databases and issues to consider in deciding on a particular database configuration. So in chapter 1, it already introduced the history about information system, and one of the word that being introduced is all about flat file, or also known as legacy system. So this particular environment of the flat file is where the users own their data file. Exclusive ownership of data is a natural consequence of two problems associated with the legacy system. So in here, in database environment, the computer processing involves two components, which are the data and instructions or the programs. Conceptually, there are two methods for designing the interface between program instructions and the data. And these are file-oriented processing and data-oriented processing. When we say file-oriented processing, ito is a specific data file was created for each application. And when we say data-oriented processing naman, is it create a single data repository to support numerous application. Typically, yung flat file or legacy system, which is eventually the first in the history of particular information system approaches, so nagkakaroon ng mga problems. Una is with regards to business culture, which erects the barriers between organizational units that inhibit wide range of integration of data. And second, merong limitations yung flat file management technology natin. And ang nagiging disadvantages ng file-oriented processing, which is eventually sa flat file, is yung data is redundant, as well as the programs, and also it varies the formats for storing the redundant data. So nagiging problematic yung flat file, although ginamit siya before, but eventually nag-involve siya to a database environment. So here is the example of flat file data management or flat file environment. As you can see, the users that I mentioned earlier in a flat file system was the owner of the data files. The user 1 has a program, then pagmamay-ari niya yung data, which is A, B, and C. The second user naman is pagmamay-ari niya yung X, B, and Y data. And user 3 has a program na pagmamay-ari din ang data L, B, and M. As you can see, each of these data that the various user have this particular data, which is yung letter B. This just illustrates yung disadvantage ng flat file or file-oriented processing, wherein there is a data redundancy. So bakit redundant? Kasi meron silang paulit-ulit na may data B, which supposed to be kung saan na-organize yung database management, and then we could be able to come up with a system that contains all of this data, and you can see that each user has their own program. Another is about the data redundancy and flat file problems. Ito is about data storage, which create excessive storage cost of paper documents and or magnetic form. Nagiging excessive storage siya kasi sa last illustration natin, all users have their data storage, and kung madami tayong users, then madami din tayong data. Second is data updating. So any changes or addition must be performed multiple times. Dito sa illustration kanina, kailangan mong i-update si data B. So each of the user data file will be updated also 3 times kung maayos yung system, edi isang update na lang. Another is currency of information. So dito, potential problems of failing to update all affected files. When there is a multiple update and if hindi properly disseminated yung update, then there will be failing to update all of the files, especially yung sa currency. So lastly is task data dependency. So dito, users' inability to obtain additional information as his or her needs change. So bakit hindi kayang mag-obtain ng information? Dahil yung user's information set is constrained ng data na possessed and kinokontrol niya. For example, in the illustration kanina, if the information needs of user 1 change to include data L, user 1's program would not have access to this data. Although data L exists in the files of another user, which is nasa user 3, keep in mind that the culture of this environment. Users do not interact as members of a user community. They act as independently. User 1 may be unaware of the presence of data L elsewhere in the organization. In this environment, it is difficult to establish a mechanism for the formal sharing of data. Therefore, data L would need to be recreated from scratch. This will take time, inhibit users' one performance, add to data redundancy, and drive data management cost even higher. And to address these issues na ito, dito nabuo yung database concept natin or yung database approach. So as you can see in this illustration, so meron tayong various users, same 3 users din kanina. We have different programs needed, then these programs will be integrated to the database management, and yung database management system will have only one storage where all of the data in user 1, 2, and 3 in the flat file system will only included in one database so that if one user needs the data, then it could be able to view that data also considering din yung access control. Dito, na-avoid natin yung data redundancy kasi iisa na lang yung file or database natin. Diba wala ng 3 B kagaya sa unang illustration kanina. Dito, isa na lang na ang pwedeng kunin ng user 1 or user 2 or user 3. And to address yung issue na about sa data, which is hindi access yung ibang data na meron yung ibang user. So, ma-address na dito to be able to extract the data but also considering yung controls. So, here are the advantages of database approach. So, data sharing as centralized database resolves flat file problems. So, first is no data redundancy. So, data is stored only once, eliminating data redundancy and reducing storage cost. So, sabi ko nga dito kanina, yung data is storage lang sa isang database where yung redundancy is eliminated na and yung cost is reduced. Second is single update. Because data is in only one place, it requires only a single update, reducing the time and cost of keeping the database current. Ito is hindi kagaya nung sa flat file system na multiple updates. Dito, yung data is only stored in one place and it requires only a single update para mabawasan yung time and cost of updating the program or even the data. Third is current values. A change to the database made by any user yields current data values for all other users. Dito, kailangan ding updated. So, the last advantage of database approach is task data independence. Kanina, merong task data dependency. Dito, task data independence naman. As users, information needs expand. The new needs can be more easily satisfied than under the flat file approach. Dito, dapat yung data ay ma-extract from the database just to consider yung controls. Kung merong advantages, meron ding disadvantages. Although na-address natin yung sa flat file, there are some disadvantages about database approach. First is it can be costly to implement. Additional hardware, software, storage, and network resources are required. Kasi you will have to incur some research or kaya bibili ng database management program so that it could be able to implement yung database approach natin. So additional cost, although titingnan natin na itong cost na ito is ma-incur natin sa data management will be beneficial pa rin compared dun sa cost na ma-incur mo sa flat file. Second is, it can only run in certain operating environments. It may make it unsuitable for some system configurations. When you purchase a database management system, it should be sa kung anumang operating system or system configuration that you have in your MVP. Last is because it is so different from the file-oriented approach, the database approach requires training users who may be inertia or resistant. Typically, from the old legacy system, transferring from database management approach, it will require you training kahit anong pagbabago ng system, it requires training. So here are the elements of database environment. In this particular illustration, pinapakita nito sa atin yung elements ng database environment. So the first element na makikita dito na pinaka-importante is yung users. The user is the one who access the database and it can access the database in two ways. First is through the user of application programs that system professionals have already prepared. The second one is by a use of query wherein it requires no formal user program. So kung magki-query ka, hindi kailangan gamitin yung user program or application program. So it could be able to access a database management there. Or if you have a user program, then it could be able to practice well the database management system. So the next element about the database environment is about the database management system or DBMS, which consists of various features na i-discuss ko sa mga next slide, which are data definition language, data manipulation language, and query language. Other element also is the database administrator who manage the database management system. And also as you can see, merong physical database which is also an element, and this illustration consists now yung elements. So we have the users that can use the application programs or use queries, also the DBMS, and the database administrator and physical database natin. So next is all about internal controls and database management system. So the database management system or DBMS stands between the user and the database per se. Thus, the commercial DBMS, such as Database Access or Oracle, actually consists of a database plus. So once you have database management system, it will also having an additional software to manage the database, especially controlling access and other internal controls, and also a software that will generate reports, which also creates data entry forms. Kumbaga, when you buy commercial database management system, dapat isang complete package yon, including the controls or the access per se, and also the software that will generate the reports. Also, the DBMS has a special software to control which data elements may be authorized by the system for a particular user. Diba, importante na merong control kasi yung database, it contains all the data already, and kung hindi naman pwedeng lahat may access doon, then they need to provide also compensating control so that limited lang yung ma-access doon sa particular data or information. So here is DBMS features. So there are 4 features na nakapaloob dito. First is program development, which is the user-created application para ma-access yung database. Second naman is backup and recovery. Copies database kasi importante yung backup system natin kapag may problema that renders the database unusable, yung DBMS can recover an earlier version. Although some data loss may occur, kapag walang backup and recovery feature, the database would be vulnerable to total destruction. The third one is the database usage reporting, which captures the statistics on database usage when they are used and who used them. The database administrator uses this information to help sa assigning authorization and in maintaining yung database. Then fourth is the database access, which authorizes access to sections of database. Also, the user programs, which makes the presence of the DBMS transparent to the user. and direct query by the user, which allows authorized users to access data without programming. In here, Data Definition Language or DDL, ano ba yung use ng Data Definition Language? Which is ito yung eventually a programming language which is used to define yung database per se. It identifies the name as well as the relationship of all data elements, yung records and files that constitute the database. Yung data definition language defines the database on 3 viewing levels. So, meron tayong internal view which is the physical arrangement of records. Dito, ang ginagawa nito is that this particular view describe the structures of the record, linkage between them at saka yung physical arrangements and sequence of record in a file. Dito, there is only one view of the database. Also, meron din tayong conceptual view which is the schema that represent the database logically and abstractly rather than is physically stored. Also, this view allows users program to call for data without knowing or needing to specify how the data are arranged or kung saan nakareside sa physical database. And this is only one view for a database. And lastly is the user view or subschema, which is the portion of the database on each of the user views. Dito, the database, unlike the internal and conceptual views, many distinct user views exist. So here is the illustration about the overview of database management system operation. These are the typical sequence of events that occurs in accessing data through a database management system. First is a user programs, which are user program 1, 2, and 3 sends a request or call for a data to the database management system. And the call is written in a special data manipulation language that is embedded in the user program. Second, the DBMS analyzes the request by matching the data elements against the user view and conceptual view. If the data request matches, it is authorized and processing proceed to step 3, which is description of data structure file and organization and access methods. If it does not match this view, the access is denied. Third is the DBMS determines yung data structure parameters from the internal view and passes them to the operating system, which performs the actual data retrieval. The data structure parameters describe yung organization at access method or the operating system utility program for retrieving yung requested data. Fourth is using yung access method, the operating system interacts with the disk storage device to retrieve yung data from the physical database. Fifth naman is the operating system stores yung data in a main memory buffer area managed by the DBMS. And kapag yung DBMS ay na-transfer na yung data to the user's work location in main memory, at this point, the user's program is free to access and manipulate the data. And kapag tapos na ang processing, yung step 4, 5, and 6 can reverse to restore the processed data to the database. So, itong data manipulation language or DML is the proprietary programming language that a particular DBMS uses to retrieve, process, and store data. Entire user programs may be written in the DML or selected DML commands can be inserted into universal programs such as COBOL and Fortran. It can be used to patch third-party applications to the DBMS. DML commands enables yung legacy application programs which originally written para sa flat file environment or earlier types ng DBMS na easily converted to work in the current database environment. If the organization decides to switch its vendors to one that uses a different DML, it will not be necessary to rewrite all the user's programs. By replacing yung old DML commands ng bago, user programs can be modified to function in the new environment. Query language is capability permits end users and professional programmers to access data in the database without the need for conventional programs. It can be an internal control issue since users may be making an end run around the controls built into the conventional programs. IBM's Structured Query Language or SQL is a fourth generation language that has emerged as the standard query language, adopted by ANSI as the standard language for all relational databases. Dito, SQL is an efficient data processing tool. Although not a natural English language, SQL requires far less training in computer concepts and fewer programming skills than many languages. In fact, many database query systems requires no SQL knowledge at all. Users select data visually by pointing and clicking at the desired attributes. The visual user interface then generates the necessary SQL commands automatically. So by reducing reliance on professional programmers, managers are better able to deal with problems that pop up. These are the functions of the Database Administrator or DBA. So the Database Administrator is a person who has the position that does not exist in the flat file environment. So walang DBA sa flat file environment kasi wala namang database management doon. Dito, the DBA is responsible for managing the database resources. And multiple users sharing a common database requires organization, coordination, rules, and guidelines to protect the integrity of the database. In large organization, the DBA function may consist of an entire department of technical personnel under the database administrator. In smaller organization naman, someone within the computer services group may assume DBA responsibility. The duties of the database administrator fall into the following areas. First ay sa database planning. Dito, he develop organization's database strategy, define database environment and data requirements, and also develop data dictionary. Second is the database design where he designs a logical database or schema. Second ay sa external users views or subschema, sa internal views of database and also sa database controls. Also, the duty of DBA sa database implementation where he determine access policy, implement security controls, specify test procedures, and establish programming standards. Also, sa database operation and maintenance where he evaluate database performance, reorganize database as user needs demand, and also review standards and procedures. And lastly, yung duty niya sa database change and growth where he plan for change and growth and evaluate new technology. Database conceptual models refers to the particular method used to organize records in a database or also called as logical data structures. And the objective of database conceptual model is to develop the database efficiently so that the data can be accessed quickly and easily. There are three main models. First is hierarchical or tree structure. This model represents data in hierarchical structure and permits only a single parent record for each child. Then second is the network, which is the variation of the hierarchical model. And lastly is yung relational model, which is more flexible model that allows users to create new and unique paths through the database to solve a wider range of business problems. Most existing databases are relational, and some legacy systems use hierarchical or network databases. In here is the relational model, which portrays data in the form of two-dimensional tables. Its strength is the ease with which tables may be linked to one another, and a major weaknesses of hierarchical and network databases. And itong relational model is based sa relational algebra functions of restrict, project, and join. In here is an example of relational algebra where these three algebra functions are examined in the following sections. First is restrict, where extract specified rows from a specified table. This operation creates a virtual table or one that does not physically exist that is subset of original table. In here, filtering out rows such as the dark blue. Second is a project where extract specified attributes or columns from a table to create a virtual table. Dito, filtering out columns such as the light blue. And lastly, is a join where build a new table or dataset from multiple existing tables, and it is a useful subset that satisfies most business information needs. In association and cardinality, when we say association, it is the labeled line connecting two entities or table in a data model. It describes the nature of between them and represented with a verb such as ships, requests, or receives. And kapag cardinality naman, it is the degree of association between two entities. Ito is a number of possible occurrences in one table that are associated with a single occurrence in a related table. And sa cardinality, ang ginagamit niya to determine is primary keys and foreign keys. So here is the crow's feet cardinalities where four basic forms of cardinality are possible. So in example number 1, assume that a company has 1,000 employees but only 100 of them are sales staff. And assuming also that each salesperson is assigned a company car but non-sales staff are not. And also in this illustration shows that for every occurrence or record in the employee entity, there is a possibility of 0 or 1 occurrence in the company car entity. When determining the cardinality values in an entity association, select a single occurrence or record of one entity and answer the question what are the minimum and maximum number of records that may be associated with a single record that has been selected. For example nga itong number 1, we're selecting an employee entity record and looking toward the company car entity, we see two possible values. If the selected employee record is that of a salesperson, that he or she is assigned one and only one company car. This particular employee record therefore is associated with one only record in the company car entity. However, the selected employee record is that of a non-salesperson, then the individual would be assigned no or 0 car. The employee record in this case is associated with 0 company card records. Thus, the minimum cardinality is 0 and the maximum cardinality is 1. In example 2, illustrate a situation in which each record in one entity is always associated with one and only one record in the associated entity. In this case, each company laptop computer is assigned to only one manager and every manager is assigned only one computer. Two short lines intersecting the connecting line at both ends depict this cardinality. In example number 3, it represents the relationship between customer and sales order entities. And we notice that the minimum number of sales order records per customer record is 0 and the maximum is many. This is because in any given period or a year or month to which the sale order entity pertains, a particular customer may have purchased nothing or 0 sales order records or purchased several times or many records. From the perspective of the sales order entity, however, every record is associated with one and only one customer. The crow's foot symbol, which gives this form of notation its name, depicts the many cardinalities at the sales order end of the association line. Next naman is example 4 where it represents a situation in which each specific item of inventory is supplied by one and only one vendor. And each vendor supplies one or many different inventory items to the company. And lastly is to illustrate the many-to-many association. We again use a vendor and inventory relationship in example number 5. This time, the company has a policy of purchasing the same types of inventory from multiple suppliers. Management may choose to do this to ensure that they get the best prices or avoid becoming dependent on a single supplier. Under a policy, each vendor record is associated with one or many inventory records, and each inventory record is associated with one or many vendors. The example 4 and 5 demonstrate how cardinality reflects the business rules in a place within an organization. And the database designer must obtain a thorough understanding of how the client or company and specific users conduct business to properly design the data model. If the data model is wrong, the resulting database tables will also be wrong. Example 4 and 5 are both valid, but different options, and as we shall see, require different database design. And here's a property designed relational tables. Each row in the table must be unique in at least one attribute, which is the primary key. And yung mga tables are linked by embedding the primary key into the related table as a foreign key. Yung attribute values in any column ay dapat lahat ay nasa same class or data type. And table must conform to the rules of normalization, like free from structural dependencies or anomalies. So here are the types of anomalies. Before that, anomalies is that improperly normalized tables that can cause DBMS processing problems that restrict or even deny users access to the information they need, and this table exhibit negative operational symptoms. Specifically, the types of anomalies are insertion anomaly, deletion anomaly, and update anomaly. When we say insertion anomaly, it is a new item that cannot be added to the table until at least one entity uses a particular attribute item. To demonstrate the effect of the insertion anomaly, assume that a new vendor has entered the marketplace, and the organization does not yet purchase from the vendor but may wish to do so in the future. In the meantime, the organization wants to add the vendor to the database. Because the vendor does not supply the organization with any inventory items, the supplier data cannot be added to the table. Second naman is deletion anomaly. If an attribute item used by only one entity is deleted, all information about that attribute item is lost. The presence of the deletion anomaly is less conspicuous but potentially more serious than the update and insertion anomalies. A flow database design that prevents the insertion of records or requires the user to perform excessive updates attracts attention quickly. And deletion anomaly, however, may go undetected, leaving the user unaware of the loss of important data until it is too late. And gaya nga nasabi ko kanina, it may result to an intentional loss of the data. And lastly is update anomaly, which is a modification on attribute that must be made in each of the rows in which the attribute appears. And itong update anomaly may result from data redundancy in an unnormalized table. The advantages of relational tables are first, remove all three types of anomalies, which is yung insertion anomaly, deletion anomaly, and update anomaly. Second is various items of interest such as customers, inventories, or sales are stored in separate tables. Third is space is used efficiently. And fourth is very flexible where users can form ad hoc relationships. Itong normalization process is a process which systematically splits unnormalized complex tables into smaller tables that meets two conditions. First is all non-key or secondary attributes in the table are dependent on the primary key, and second is all non-key attributes are independent of the other non-key attributes. In other words, it involves identifying and removing structural dependencies from the tables under review. When a normalized table are split and reduced to third normal form, they need to be linked together via foreign keys so that the data in them can be related and made accessible to users. Here are the steps in normalization. First, sa user view, merong unnormalized table, then kailangang i-remove yung repeating groups para magkaroon ng first normal form or 1NF. Sa first normal form, kailangang i-remove yung partial dependencies para magkaroon ng second normal form, and dito, kailangan ding i-remove yung transitive dependencies para magkaroon ng third normal form or 3NF. And lastly, sa 3 and F, kailangang i-remove yung remaining anomalies para magkaroon ng higher normal forms. In here, accountants and data normalization, which data normalization is a technical matter that is usually the responsibility of system professionals. The subject, however, has implications for internal control that make it the concern of accountants also. For example ay sa update anomalies where it can generate conflicting and obsolete database values. And also sa insertion anomalies where it can result in unrecorded transactions and incomplete audit trails. And also, deletion anomalies can cause the loss of accounting records and the destruction of audit trails. Although most accountants will not be responsible for normalizing an organization databases, they should have an understanding of the process and be able to determine whether a table is properly normalized. In designing relational databases, this section examines the steps that involve in creating a relational database. We should know that the database design is a portion of a much larger system development process that involves extensive analysis of user needs. With this, it focuses on the 6 phases of database design or phases in designing relational databases, which are collectively known as viewing model, and these are: first is identify entities, where sa view modeling, it begins to identify the primary entities of the organization, and that entities are things about which the organization wishes to capture data. And this will be used to construct a data model and ultimately the physical database tables. Second is construct a data model showing entity associations. Dito, it determine the associations between entity and it model associations into an ER diagram. And that associations represent business rules and that rules are obvious and all the same for all organizations. Third is add primary keys and attributes. Dito, it assign primary keys to the entities in the model and the analysis should select a primary key that logically defines the non-key attributes and uniquely identifies each occurrence in the entity. And sometimes this can be accomplished using a simple sequential code such as an invoice number, check number, or purchase order number. In adding attributes, every attribute in an entity should appear directly or indirectly in one or more user views. In other words, if stored data are not used in document, report, or a calculation that is reported in some way, then it serves no purpose and should not be part of the database. Fourth is normalize and add foreign keys. Dito, it remove repeating groups, partial and transitive dependencies. And also, it assign foreign keys to be able to link tables. Then, construct the physical database where dito, it create the physical tables and populate them with data. This is an involved step that must be carefully planned and executed and may take many months in a large installations. Programs will need to be written to transfer organization data currently stored in flat files or legacy system databases to the new relational tables. And yung data currently stored on paper documents may need to be entered sa database tables manually. Once this is done, the physical user views can be produced. And user views restrict users from having access to unauthorized data. And lastly is prepare the user views. It normalizes tables that should support all required views of system users. And also, user views restrict users from having access to unauthorized data. Next naman is the distributed data processing or DDP, where it is organized around several information processing units or IPUs distributed throughout the organization. Distributed data processing is not always mean to total decentralization. Each information processing unit is placed under the control ng end user. Dito, yung information processing unit in a distributed data processing system are still connected to one another and coordinated. Typically, yung distributed data processing use a centralized database. Alternatively, yung database can be distributed similar sa distribution of the data processing capability. Distributed databases fall into two categories. First is partitioned, and second is replicated databases. As you can see sa illustration ng distributed data processing, merong central site or decentralized database where it connects the site A, site B, and site C. So sabi ko nga kanina, yung mga several information processing units are distributed throughout the organization. So as you can see dito sa illustration, yung centralized databases are distributed through site A, site B, and site C. In here, under the centralized database approach, remote user sends requests via terminals for data to the central site, which processes the request and transmit the data back to the user. And yung actual processing ng data is performed at the remote of information processing unit. Dito, yung data is retained in a central location. And yung central site performs the function of a file manager that services the data needs of the remote users. So here are the advantages of distributed data processing. First is cost reductions in hardware and data entry tasks. Second is improved user satisfaction since control is closer to the user level. Third is improved cost control responsibility. And lastly is yung backup of data where it can improve through the use of multiple data storage sites. Kung merong advantages yung DDP, meron ding disadvantages. First is loss of control. Second is mismanagement of resources. Third is hardware and software incompatibility, where dito, distributing responsibility for the purchases of software and hardware can result in uncoordinated and poorly conceived decisions. Fourth naman is the redundant task and data, where dito yung autonomous systems development activities throughout the firm can result in the creation of redundant applications and databases. Panglima naman is consolidating incompatible tasks, where dito yung redistribution of IT functions to user areas can result sa creation of many very small units. Pang-anim naman is difficulty in attracting qualified personnel. Dito, yung mga end users are typically not qualified to evaluate the technical credentials and relevant experience of prospective IT employees. And lastly is yung lack of standards where for the aforementioned reasons, standards for system development, documentation, and evaluating performance tend to be unevenly applied or non-existent in the distributed environment. When we say data currency, it occurs in distributed data processing with a centralized database. When we say data currency, it is the firm's data files reflect accurately the effects of its transactions. Achieving data currency is critical to database integrity and reliability. However, in the distributed data processing environment, this can be a challenging task. During transaction processing, data will be temporarily inconsistent as records are read and updated. When we say database lockout, the procedures are necessary to keep information processing units from reading inconsistent data and from writing over a transaction being written by another information processing unit. Itong first category ng distributed databases, which is partitioning approach, splits the central database into segments or partitions that are distributed to their primary users. The advantages of this approach are: first is storing data at local sites increase users' control. Second is permitting local access to data and reducing the volume of data that must be transmitted between sites improves transaction processing response time. And last is partition databases can reduce the potential for disaster. By having data located at several sites, the loss of a single site cannot terminate all data processing by the organization. Itong deadlock phenomenon in a distributed environment is possible that multiple sites will lock out each other, thus preventing each from processing its transactions. Ito ay especially a problem with partition databases. It occurs when multiple sites, sabi ko nga kanina, lock each other out of data that they are currently using. And one site needs data locked by another site. Special software is needed to analyze and resolve conflicts, and yung mga transactions may be terminated and restarted. As you can see dito sa illustration na to, it illustrates three sites and their mutual data needs. Notice that site 1 has requested and locked data A and is waiting for the removal of the lock on data C to complete its transactions. And site 2 has a lock on C and is waiting for letter E. And finally, yung site 3 has a lock on E and waiting for letter A. And the second category of distributed databases is replicated databases. In some organizations, the entire database is replicated at each site. Replicated databases are effective in companies where there exists a high degree of data sharing but no primary user. And dito, it supports read-only queries. And sa duplication of the entire database for multiple information processing units is important. Data traffic between sites is reduced considerably, and each site processes only its local transactions. And yung mga different transactions will update the common data attributes that are replicated at each site. And itong mga site na to will possess uniquely different values after the respective updates. Concurrency problems and control is the presence of complete and accurate data at all remote sites. System designers need to employ methods to ensure that transactions processed at each site are accurately reflected in the database at all other sites. And a common used method for concurrency control is to serialize transactions. Dito, this involves labeling each transactions by two criteria. First is special software groups transactions into classes to identify potential conflicts. The second part of the control process is to timestamp each transaction. Dito, a system-wide clock is used to keep all sites, some of which may be in different time zones, on the same logical time. And itong time stopping na ito is it prevents and resolves conflicts created by updating data at various information processing units. Lastly is the distributed databases and the accountant. Dito, the decision to distribute databases is one that should be entered into thoughtfully. There are many issues and trade-offs to consider, and some of most basic questions to be addressed are: first is, should the organization's data be centralized or distributed? Second is, if data distribution is desirable, should the databases be replicated or partitioned? Then third question is, if replicated, should the database be totally replicated or partially replicated? And lastly is, if the database is to be partitioned, how should the data segments be allocated among the sites? Dito, the choices involved in each of these questions impact the organization's ability to maintain database integrity. The preservation of audit trails and the accuracy of accounting records are key concerns. Clearly, these are decisions that the modern accountant should understand and influence intelligently. That would be the end of my report. Thank you for listening.